Hello, Rockets. Happy Monday. Welcome back. Remember, Rockets are respectful, responsible, and safe. We listen, negotiate, and value people's time. And I appreciate you valuing my time by watching this video and valuing your time by taking out the time to care about your education and supporting me in your learning. All right. Make sure you have your paper and pencil ready. Go ahead and draw on your paper this circle. Doesn't have to be perfect, just do the best of your ability. And as you can see, look how I numbered it. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like a clock. And that's what it's going to represent. No, we are not telling time. We're doing something else with angles. So go ahead and get this drawn on your paper. If you need to pause the video to do it, please do so. All right? So I want to do a quick review. Quick review using our anchor chart. Get ready. Point. Line segment. Stop. Stop. Line. Keeps going in both directions. Keeps going in both what? Directions. I've got a ray. Keeps going in one direction and stops in the other. Then I'm moving on to my angles. I know I have an angle when two rays come together and share a common endpoint, meaning the same endpoint. So if it looks like the letter L, and it's got that square corner, I've got a right angle. I've got a right what? Angle. Now, acute and obtuse. A lot of people kind of mix those two up on their quiz. So look at me. If I am in acute angle, I am acute and tiny, less than 90. Greater than 0, but less than 90. Look at how I'm coming in. Remember, I keep saying, well, that acute, I think I'm so cute, I really don't want to give you a hug. So I'm kind of coming in. But if I'm an obtuse angle, I'm opening all the way up because I want to give you a great big old hug. So let's go over it again. Acute angle, acute and tiny, less than 90. I don't really want to give you a hug because I think I'm too cute to give you a hug. So I'm coming in to kind of shy away. But if I'm an obtuse, I'm opening all the way up to give you a great big old hug. Wait a minute. Then I have my straight angle. My straight angle, which is worth 180 degrees. Great job. Then we went on to describe lines. Parallel, 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 never meet, never cross, same distance apart. Intersecting, intersecting, meet or cross, meet or cross. Perpendicular, perpendicular, square corners, square corners, also known as right angles. All right, great job with reviewing. Now, normally, when we measure angles, we would use this thing here called a protractor. Say that with me. Protractor. This is a tool that I enjoy using that can help us not only measure angles, but it can help us draw angles. But because most of you don't have a protractor at home and you don't have me at home with you to help you to show you how to hold the protractor correctly and to draw and measure your lines and angles, we're not going to use the protractor to go ahead and draw and measure. We're going to look at measuring angles by their rotations. So somewhere on your paper, I want you to put measure angles by rotations. Measure your angles by rotations. We could use a protractor, but we can also do it by their rotations. All right, put my protractor down for just a minute. So let's look at this clock. So I want to draw some hands on my clock. So I want my long hand to go straight up there to my 12 and my short hand to go right over to my 3. What kind of angle does that look like? Right angle, like the letter L. Straight angle. Obtuse angle. Or acute angle. If you said a right angle, I would agree with you. So this angle, based upon its rotation right here, is worth 90 degrees. 90 degrees, put my degree sign, or 1/4. Well, wait a minute. Where did she get 1/4 from? Well, hold on. What if I took this clock and did like that? And did like this? Wait a minute. Do you see a right angle there? You see a right angle there? You see a right angle there? How many equal parts do I have? 1, 2, 3, 4. 4 equal parts. And right now, this angle in the black is 1/4, which is 90 degrees. Stop. Let me back this thing up a little bit to make sure you're following me. Erase this for a minute. Go back and look. You agreed with me that this clock is showing an angle, a right angle. And we know that square corner, it looks like the letter L. So you're telling me that it's equal to 90 degrees, because we already learned that. We already know that about the clock, about this angle. I'm sorry, about this angle. But wait a minute. Let's look at this. Don't I have a right angle here, and here, and here? I do. I've got a right angle there. 1, 2, 3, 4. 1/4. So that's where my 1/4 is coming in. Let's rotate this angle. Let's rotate this angle some more. Okay. Uh-oh. Miss Haynes is going to get her drawn a little bit better. Ooh. Is this a right angle looking like the letter L? What kind of angle is this? Straight angle, right? Straight angle. And I told you a straight angle is worth 180 degrees, also known as a half. Where did Miss Haynes get this half from? Oh, she cut the clock in half. My marker's not working. Hold on. She cut that clock in half. I split it down the middle. 180 degrees. Well, wait a minute. If I said that the right angle here was 90, and we said it was another 90, and another 90 here, and another 90 there when we broke it up into fourths. 90 plus 90. What is that? 180. So half of the clock is equal to 180 degrees. Make sure you get your stuff down. Wait a minute. What if I did it the other way? Is that a straight angle? You betcha it is. I cut the clock in half. 180 degrees. I cut it in half. Well, wait a minute. This half would be 90 over here. Excuse me. This top half would be 180. This bottom half would be 180. I'm looking at this half. But wait a minute. If I turned it back into my right angles, 90, 90, 90, 90. I know this is a lot. This is just our introduction today. Keep thinking, we're going to go over it some more tomorrow. Uh-oh. Now she's getting really sneaky. Really sneaky. Ah! She came out with that angle, but then she went all the way around. I made a complete circle. A complete circle. A complete circle is 360 degrees. I went around the whole thing. 360 degrees. I made a whole circle. Get that down. Get that down. Quickly, I want to review and look over your notes when we're done. So I started out like this. You told me that looks like the letter L. So you said it was a right angle. I'm using rotations to measure my angle. So this is equal to 90 degrees. Also 1/4. Where did I get that 1/4 from? Well, wait a minute. If I did it like this, remember? Look. I've got 4 right angles. 1, 2, 3, 4. This one is 90 degrees. 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 So 90 degrees here is 1 out of 4. 1, 2, 3, 4. Make it a little bit sense? This is another 1/4. This is another 1/4. This is another 1/4. All right? Then I did it like this. Got a straight angle. Straight angle. 180 degrees. 180 degrees here. 180 degrees here. A half, and that's the other half. Making sense? 1 out of 2. 1 out of 2. Then I did it like this. Uh-oh. And I made a complete circle. A complete circle. I went all the way around. 180 and 180 on the other half. 180 plus 180. 0 plus 0 is 0. 8 plus 8, we know about doubles, is 16. Uh-oh, I need to regroup. 1 plus 1 is 2, plus 1 more is 3. 360 degrees. Go ahead and get that in. We will pick up on tomorrow, Rockets. I know this was a bit challenging, but we're going to get this. See you later.